So now we're going to go down to the micro level. The committee itself, I think you see how it works. There's a group of about 20 or 30 people that have frequent telephone conversations. Documents are passed back and forth, and there's a pretty good agreement on where we, or how we get to various milestones down the road. Now, in this particular case, I want to take show you an example of a micro look that we can take within our group. So we have the group, and then a certain expert might be assigned to take a look at something in more detail. So that's what we're going to do now. So the question that some of us had was some of the infrastructure costs that have been reported in the literature. And we basically survey the literature, see if those numbers make sense or which source we should use as opposed to which we may not want to use. And I'll lead you through the path that we followed, okay? So the infrastructure in our terminology includes everything from electric generation to the car. In other words, we have a power plant, we have the T&D, transmission and distribution, we have the electrical substations, the panels, and finally the J-plug connector that plugs into a car. So where in that long chain could there be problems? Now, one thing that we did several years ago is took a look at the grid. Do we have enough grid capacity in the US or state by state to meet a certain level of EV rollout? And the first thing we looked at was at California, because that's where we're probably going to see some of the first significant action. And a model was done of the state. Every power plant was modeled, every T&D line. Next, Jenna. And we found out that in the state of California, if we do semi-intelligent charging, in other words, you can't plug your EV every time you get home at 4 p.m., everybody plugs their electric vehicle, and that doesn't work. But if we do it more intelligently, there probably isn't a serious generation or T&D issue in the state of California with an EV rollout that we projected to occur to a certain level over the next 20 years. And these were the growth curves we used. The left, you might say, is 2011, and the right would be 2030. And if you have various electric ranges, the blue bars have to do with a more significant battery size, such as the volt, and the 15-mile all-electric ranges, a little bit high for the plug-in hybrids we talked about. So this was our driving force assumption, okay? So if you looked at that over that 20-year period, and you looked at the base load, which is the big yellow block here, and you look at what the EVs would be imposing on that, it's small. As you see the small triangle in the upper right-hand corner. And so it's not a big deal. And the utility experts in our groups assert that that can be handled in the normal course of business, the normal growth of the grid, and that it's not a concern. We also took a look at that in the Northeast. Same conclusion. EPRI's looked nationwide, same conclusion. So that part of the infrastructure is in good hands. What's a little bit more of a question is down at the end of the line where we charge these cars. So I'll let you read that. I point out in the lower right-hand corner that there's a terminology and nomenclature that we use for these charging devices. If you do it at home and you run it on 120, it would take you about 16 hours to charge a BEV. Now, a BEV is an all-electric vehicle. Think Leaf, for example, or cars equivalent to that. Not much load. Plug in another hairdryer, then that's about the load that you would have. Takes a long time. So there is a expedited way to charge vehicles, and this could be at home or on a commercial basis, where we use 240, and that's the so-called level 2 charging. It takes you a couple of hours to charge a battery electric vehicle. Now, if you want to try to approach the charging rate of a gasoline engine, and we heard yesterday from Rusty that the energy rate is 10 to 20 megawatts when we're charging a gas tank with liquid fuel. Then we have to go to a still higher voltage, and that we call level 3. It's up to about 200 kW, a significant electrical load, and that's what we call fast charging. And the idea there would be that somebody can pull in to a charging station, run an errand, go shopping for a bit, and charge their car if it's low. So that's the nomenclature.